Good morning, and thank you very much for coming to this session because it's morning and yeah. But today I'm going to talk about zero downtime deployment, and basically I'm talking about zero downtime deployments because this means that if we do zero downtime deployments means that we're going to hit the market more often, and if we hit the market more often, it's a great advantage against our competitors. I'm Alex Soto, I work in Red Hat. And well, I'm the creator of loveofthejobs.com, and yeah, my Twitter is Alex Soto B. And if you want this sticker of Duke with the wizard, I have some. So after the session, feel free to come and pick it once. And before we start, there is also a raffle that you just need to follow me on Twitter with a picture. You mention me and with the hashtag microXchg, and then I'll raffling 3 ebooks of testing Java microservices, which is I'm the author. But in any case, if you are, if you don't get it the prize, you can even use this discount, which is a 40% of discount of the book. If you have any question, that you can raise your hand in the middle of the session. It's not necessary to wait until the end. You can do it at the end, but if you want to do it just in the middle, that's fine too. So some years ago, that now seems ages, right? We developed something like this. It's a monolith, right? Everyone knows how it looks like. Internally, it's something like that, right? So we have some modules inside our own monolith. And yeah, it was really easy to deploy, right? It was just one, let's say, WAR file that you deploy it. And maybe you were doing this like once every 3 months. Well, maybe some of you said 3 months. Yeah, we're taking 6 or 1 year. We're deploying to production once per year, right? But since it was like, let's say once every 3 months, it was perfectly fine to just put a maintenance window, right? That when people reach there, said, we are in the maintenance, return in 5 minutes and you will get the new version, right? Something like that. This is something that we used a lot. And that's perfectly fine in monolith because at the end it happens once every or twice every year. But then 2 years back, we start breaking this monolith, or all the models in the monolith, we start to spreading them out until we get it a distributed architecture, right? We have distributed all these services across a network, what is called a mesh. And you can see that this is like a graph of structure, so the things are becoming somehow interesting. Even each of the service has its own database, and we have multiple entry points. And this is why we need also an API gateway, right? Because it's not just one entry point, just several services that can serve requests and responses. So one of the things that happens with microservices is that you can deploy, or you should deploy, all your services independently. So you can just deploy one service and then another service, and there should not be any dependency between them. And this means that probably you are deploying several times per day on your production cluster. Maybe your service is just once per day, but maybe you will start with one service and then another one service in the evening. So now there is a problem with the downtimes, because if you are updating this service and you just shut it down, it's not just that this service is down. It's down all the services that depends on that service. So it's really important to get zero downtime deployments in a true microservice architecture. So how we can achieve this, it's like changing how we are doing things. And we need to change how we perceive production. And one of the key points here is that in the past, when we said that we are deploying our application, what we really mean is that we are releasing our application, right? But now with microservices, and we can think about that deploy is not release. One thing is deploy, which is just take your service and put it into your production cluster. And another thing is release, which is start sending some public traffic to this service. So now we have 2 phases, deploy the service and release the service. And thanks of this change in the release process, there are several techniques to do it. And here we are going to, or I'm going to explain you the typical ones. The first one is the blue-green deployment. It's like we have two identical environments, and we just balance between them. So we have something like that. We have our build, which is our new version of the service. And then we have that all public traffic goes to the blue version of the service, which could be the V1. Then we just deploy our service to production. And then maybe here in production, we can even run a smoke test or, I don't know, or even integration tests against this piece of service, because at the end, this service is deployed on your cluster, in your production cluster, so you can do some checks. And then when you think that everything is ready, the only thing that you do is change the route from the blue to the green. And when you have done this change, all the traffic goes to this green service. And you start monitoring. It's really important to monitor how it's behaving, this new service. And if it behaves similar to the previous one, then you know that it's a good version and you can continue. And if not, you just need to switch back from green to blue, and then in just a moment, you are again with the old version, right? So this is one thing that you can do if you have a clear difference between deployment and release. But of course, the problem with this is that it's all or nothing. So suppose that you have added a regression, and you switch from blue to green, you start receiving all the traffic there, and then this new version is failing, and all your users will be affected by this downtime. Probably you are monitoring this, and in just a matter of 3-5 seconds, you will get back to the old version. But again, your customers or your clients will perceive that you are doing something that it's failing on their side. So there is another technique which is called Canary Releases. Everyone knows why it's called Canary Releases? Yeah, everyone? Okay, so it's the mining call to putting a bird there and check if it dies or not detect the poison gases. And we're going to do something similar in software. I mean, we're not going to kill any bird, of course, but we're going to use a similar approach in the sense that we have our version, our new version, which is this yellow point, and then all the public traffic goes to the blue service, which is the V1. Then we just deploy the service to the production cluster, and we start sending, for example, 1% of the traffic. So instead of sending all the traffic to the new version, we just send 1% of the traffic. If it goes well, we can start just sending 5%, 10%, 25%, 50% until we have this 100% traffic send it there. Nothing new. But as you can see, we still have one problem. And this problem is that if you are, if you have, like, for example, one request per minute, probably 1% of the request, if it fails, it's just maybe one client, right? But if you are Facebook, for example, and you get it 1% of the traffic to the new version, and the new version is failing, 1% of the all traffic of Facebook, probably it's a lot of users. So it's not a good idea to use this approach. And for this reason, Google, Amazon, and Facebook and other companies start doing one thing that is called dark launches. And dark launches is a set of techniques to test on production without the end user noticing it. And there are a lot of techniques. I mean that I could create a talk just explaining all these dark launches techniques, but for the sake of, let's say, most used approach is this one, which is called shadowing traffic. Now you can see that it's somehow different, because I have the users goes to the router, and the router send two requests. One request to the B1, which is the blue one, and another request to the green. So you're duplicating your request to both services. But the difference is that the blue ones do a response, and this is a response that gets back to the user. Meanwhile, the green one is just a fire and forget request. It just sends the request, but they do not care about the response. In this sense, we can just test our new version without any problem before releasing to all public users. So you can just monitor your new version with real traffic, check if it works or not, and if it works, then you can start, for example, doing a canary. Of course, how to apply all these techniques, it depends on the platform where you are running. But probably if you are into the microservices world, probably you are using Kubernetes or OpenShift, which is like the Kubernetes for enterprises, you can think about it. And because at the end, Kubernetes is the de facto platform for microservices. But if you are into Kubernetes, probably you will ask yourself how I can apply all these techniques, that Canary Releases or the launches with a plain Kubernetes. And the answer is that it's really hard, and probably you will die in trying it, right? And for this reason, there is Istio, and just Istio is, you know what is Istio? Everyone knows what is Istio? Well, Istio, I will explain. Istio is a service mesh, and a service mesh is a dedicated infrastructure layer for making service-to-service communication safe, fast, and reliable. And Istio just, at the end, it's a CRD of Kubernetes. So it can work in bare metal. There are examples in the website for using, for example, with Mesos or with virtual machines. But let's say that it's mostly for Kubernetes. And basically, what you're doing is something like that. Before Istio, we have all our services. That if you're in the Java ecosystem, you have the JVM. Then you put the JVM inside a container. And then you have all these, let's say, I like to call these cross-cutting concerns. Like, for example, how to discover another service, how to do a load balancer, how to do the resiliency. Probably most of you are using Istrix for this, right? So you're putting Istrix inside your code. For metrics or for tracing, so you are just having a lot of bloated code inside your service. But what's even worse is that probably you have more than one service, and what you end up is by doing copy-paste from one service to another service, right? Because nobody does copy-paste, right? Never. So, yeah, that's fine. This is how we work before Istio, but now with Istio, it just works something like that. It's like, take your JVM, put all your logic inside your service, and then all these cross-cutting concerns goes inside a sidecar container. Sidecar container is a container that lives inside the pod, and it has the same life cycle of the pod. And this means that in each pod, what we really have is two containers. One, this is the sidecar container, another one, which is the, let's say, service container. And if you, more specifically, each of these side container contains an envoy proxy. Envoy proxy is like HA proxy, for example, but it's thought for microservices, thinking in basically Kubernetes. Although it can be used outside Kubernetes because it's written in Go, but I think it's Go OC, I don't remember. But that it was created from scratch to work in this kind of architectures. And with Istio, we can route traffic. So we can do things like send traffic to this service, or send traffic to this other service, or send traffic to service V1, or then send traffic to service V2, or do a canary, send 100%, 99% of the traffic, so on. Also can be used for mirroring, what we have seen. Just said, okay, I want to send the request to these two services, but just take care of the first service for getting the response. Or you can do one thing that is called dark canaries. And dark canaries is when you start doing like a canary release, but instead of doing for percentage, taking other parameters. For example, the value of a header, or the IP of the user. So you can do things like all the users that come from this range of IPs goes to this version, and if not, goes to the other version. Also implements circuit breaker, which everyone knows from Histrix, so it allows you to make your services more resilient. Also implements chaos engineering, but please be aware of it. Because everyone does or everyone now today are doing chaos engineering because just Netflix is doing it. And I'm going to explain my experience that I was in a company. They asked me to introduce them Istio and so on. And they said, "Oh yes, we are into chaos engineering. Oh yes, and how is it going?" Wow, it was really bad. Really? Yes. And why? Yeah, because we tried to kill all the cluster and see what's happening, and nobody could reach our cluster. And it was like, yes, usually happens this, that if you kill all your cluster, nobody can get access to the cluster, right? This happens, yeah. So it's fine to do chaos engineering, but maybe you need to do you have a learning curve, and maybe you should start with less critical experiments. Also, it implements security. So you can make communication between services using HTTPS. Although you are not programming with HTTPS. Everything is managed by Istio. You are doing HTTP, Istio converts this HTTP to HTTPS, and then send the communication to the service using HTTPS, take care of all the certificates management. Also, you can implement blacklist, whitelist between services, MTLS, or for example, you can use JWT. So the verification of the JWT token happens automatically. You don't need to verify anything. Istio is smart enough to say, okay, this is a token, I'm going to verify it. Okay, it's nice, then I'm going to pass this token to the service, and if not, it just returns back to the caller. And this is done automatically. And finally, it also have observability. By default, Istio comes with Prometheus and Jigger. So you don't have to do anything, and all your architecture are monitored automatically. And if you have seen any talk of me or any other mates about Istio, you see that now it's time for the demo, right? And they explain you a really simple demo, which is like service A calls service B, and B service C. This C returns on a string, we just concatenate it to B, and then this string is concatenated to A, and then it's returned, right? And they start showing you how to do a Canary Release and a blue-green, and so on and so forth. And it's really nice, but it's really simple, right? And the real world is not a Hello World or a Mickey Mouse project. So now I'm going to explain you, let's say, how we can deal with persistence. And when I say persistence, first of all, I'm talking about a persistence that has an ephemeral state. As you know, a persistence is not forever in some cases. Ephemeral state is this persistence that is, for example, a shopping cart, where you store something from a period of time, and then you just clean it. So in the past, when you have monolith, usually what I use is that I have a router, and I have the version 1 of my service, and I have something that was called sticky sessions. I'm sure that everyone here has fight someday with the sticky sessions. And then when I have my shopping cart, I'm just creating a session in the version 1, and then a sticky session take care of redirecting all the traffic from this client to the same service of version 1, because it's where the shopping cart lives. The problem is that when I do a blue-green deployment and I change to version v2, well, the cart is gone. Of course, you could say, yeah, but you can do a Canary Release. And yes, you can do a Canary Release, but then maybe you get it, the 1% of your traffic is the one who has the cart on the other server. So it's exactly the same problem. To fix this, what you need to do is just use an in-memory data grid. An in-memory data grid is a data structure that resides entirely inside RAM, and it's distributed among multiple servers. I mean, there is a lot of them. There is Redis, there is InfiniSpan, and so on and so forth. And basically, you can think about it like you have a distributed RAM, where when you just have, for each of your version, one of these in-memory RAM, and then when you just create a shopping cart, it can be created by using version 1 or version 2, but the shopping cart is spread across all these in-memory cluster. So effectively, you have the same shopping cart in every server. So if you do a blue-green, then it's really easy. You just shut down v1, and it just works, because all your servers have a version of the shopping cart. So let me show you a demo about it, so you can see how it works. I have here let me change this first. Okay, this is a shopping cart. Notice that I have 0 on the shopping cart, and the important thing here is that at the bottom, you see, I think that you can see it, right? That you can see is movies v1, right? This is the host name who is serving the request, or this request. So now I can start buying something, for example, probably all of you wants to buy Captain Marvel, but I don't know if you want to Avengers, since we are in there. Any other that you see? Look. Alita? Anyone? Alita? Yeah? We're going to put 2. Okay. 2 Alitas. So you can see here that I have 3, right? I mean that I have 3? Yeah. Okay, now, what's happening if I want to release a new version? And I'm in Istio. Let me go here. The only thing that I need to do is just apply a resource. Yes, sorry. Then if you see here, I have some files, and one is the virtual service v2. Basically, this virtual service is a resource of Istio, which is where you define where you want to send the traffic. And what I'm saying here, well, like you can see, is that I want to send all the traffic to version 2 and not to version 1. So I'm effectively doing a blue-green deployment. So I just need to do istio-ctl replace -f virtual service v2. Okay. Okay. Let's hope that's going to work. Now I've just changed it. I've routed from v1 to v2. So I can go here. I can refresh. Obviously, you still see that there are 3 movies there, but now the one who served was v2. Before it was v1, and now it's v2, and I've not lost the shopping cart. And I can even navigate here. You see all the books, and here that the movie v2 is the one who served the request. If you want to see this how it's working now, it's something like this, where I have in this case, I have a Redis, a gateway, and then I have the movies v1 and the movies v2. So I can switch from v1 to v2 without losing the shopping cart. Let me now stop this. Now I'm just shutting down the cluster, and I'm going to start a new cluster for the next example. Okay, we've seen a demo of ephemeral state, but now let's go to the persistent state. Persistent state is when there is a database there. And the problem is not the database itself. The problem is when we want to do a change in the database. I'm going to explain, let's say, for me, it's the complicated one. I mean that if you understand this one, you can, deduct all the other ones, all the other cases, insert a column, change a type, and so on and so forth. This, for me, is like the most generic one. And it's when I want to update a column name. I have a column name in my database, and I want to update it to another. I mean that in this case, I have version 1, which goes to the column name. And basically, I want to start doing a canary between, that 99% and 1%. And now the column name, it's called full name. So I've renamed the column from name to full name. And of course, now it does not work, right? Because the 99% of the traffic is not going to work because it's going to say that column is not found. But even it's not only this. It's also about that if I do a blue-green, maybe I change to green, all the traffic works. But if you have added a regression, then you will like to switch back to v1, and then you will have some problems with the column. So the ways of working is doing 3 versions. So you need to do 3 steps before going to, before say that you have succeeded and completed the rename of the column. Again, you have the version v1. The version v1 just read and write to a column called name. And then you create another column, which is called full name, which now is empty. And then I create version v2. Version v2 reads from name and writes to name and full name. And then I can do the switch to this new version. Notice that if there is any problem, I can switch back to v1 without any problem, because v2 is writing to name and full name. So when my traffic goes through version v1, it will get all the updates. The next thing to do is okay, now I have a version v2 which reads from name and write to both, and now I'm going to create a version 3, which is the one who do all the things. The thing is copying all data from name to full name. Remember that full name was empty. Now I'm going to copy everything from name to full name. The reads goes from full name, so now my v3 is getting all the data, and the write go to both. So again, if there is a problem in this v3, there is no problem. Since write happens to both columns, when I switch back to v2, I will be able to get all the data inserted by v3. Finally, if everything works, then I will have v3, which just writes to both and reads from the new name. Then before, it just needs to read and write from the new column name. Again, if v4 you have added any regression, you can switch back to v3, because since the reads happens from full name and everyone is writing to full name, you are not going to get any lost. So let's see an example of this. I think I am okay. First of all, okay. qctl get pods. Notice that here I have a Postgre, and what I'm going to do now is qctl exec going into Postgre. I'm just getting into pod. So you and then I can do psql -u. I think that it's admin select from condition. No, and whoops. I think it was maybe it's movies. No, wait. Let me, because I know I don't. What? Semicolon. Ah. Oh man. Okay, select from record. Okay. Now I have the name with 2 movies, a Star Wars and a Star Trek. And I can go here, I can do a call to here, and you see that I'm returning the Star Wars and Star Trek movies from version before. I switch version before is the base one. Now, what's happening if I add a new movie? Well, let's do another thing that is like qctl replace -f ist2 files to service condition b5. Okay, now all the traffic goes to b5. If I do a call, you can see. Oops, sorry. Let's wait. Actually, I think that what. Okay, I need to deploy b5. To deploy b5, I just need to do qctl apply deployment b5. Notice that I'm just doing the kubectl apply as usually, but I'm just adding istio.ctl to enrich my deployments with all the istio. Finally. Now I can just do the call. It's not healthy yet. Oh, it's booting up. Okay, now I have the version B5 with the two movies. Then I can add a new movie. Let's add, for example, Infinity War. Notice that this is in the B5. Then I can just switch back to B4 again. And now if I do a curl, I added again, well, you will see twice. You see that the V4 contains also the Avengers Infinity War. So although I've switched from 5 to 4, I've not lost the insert that I've done in the B5. And if I do here this select, you see that now I have a column called movie name, right? Write it in both columns. This is what I explained before. Now suppose that we can just go again to B5. And everything still works. Now let's deploy a new version, which is the B6. Now I need to wait. Now in B6, what I'm doing is just copying data from name to full name, and then write happens in full name, but reads are in both. And reads in full name, writes in both. And now I can just do a call. Obviously, as I wait, I need to redirect the traffic to this B5. I can do now a call. And now I'm going to B5. I'm not lost any update. And if you do again this select, you see that now the movie name contains all the data because I've copied. Again, I can do Again, I can do a call, adding another. For example, I can add. Let's see. Frozen, we can add Frozen, for example, in this new version. Now I can do the call again. Of course, I get Frozen, and if I do the select, you see that Frozen is added in both. And then the last step, let me delete all minus. Let me delete one version, V5. And then I can just do a kubectl apply the version V7, which is the last one, which now it just reads and writes in the new column. And I can do istio.ctl, replace, I start sending traffic to V7, and it's not yet deployed. Okay, now I can do a curl. You see that now I see Frozen here, and even I can go back to B6, which is the previous version. And again, I can just do a call, and V6, I still have Frozen. So in fact, I'm not losing any insert. So if you want to learn more about this, you can go to this istio tutorial. Istio tutorial, I think that it's a more completed one. It's done by Red Hat, and we have everything there. I mean that if you go to istio documentation, you will face yourself trying to decrypt everything, or a lot of parts, probably the complex ones. And here everything is explained, so you can follow in a step way. And it's time to relax. We are finishing. The first one is that you need to move forward. I mean, that you need to think about if you want to keep this zero downtime deployment or not. And if you think that it's worth and you want to hit the market, just stop thinking about how you did things before and start thinking how you should do things with the current technology. For example, with Kubernetes, you've seen that it's really easy to deploy and release things in a different way. But of course, proceed with caution. The first thing is that the last step that you will do, that I've not explained it, is that you need to delete the old column, right? Because you are duplicating, I mean, that you will have somehow duplicated all the data. But probably no DBA is going to allow you to do that, right? Because it's a risk operation. So just proceed with caution and learn a lot. And when you're curious, you have a lot of interesting things to do. You can learn about Istio, you can learn about building reactive microservices, all this book of migrating to microservice databases, which are free. You only need to go to developers.redhat.com, you register, and you can download it for free. And that's all. If there is anything, you can do it on Twitter, send me an email, or visit my, my blog. Thank you. And now, I have here, 1 second, let's see, there's 3 books. Wait. I will put it longer now. Okay, these are the winners. Serverless Chaos, Fish Bouch, and Daniel. Daniel Bryant. I mean, after the session, you can come here, pick up some stickers, and you and the winners, just the code. Thank you. Any question? Well, because it was like, I've not seen any questions. Maybe, but
Oliver.
But we still have 5
Here, Mike is coming.
Hi. One thing, which is more of a remark than a question. So we also trying to do like zero downtime migration of databases. And there's one caveat when you add a column, especially adding a non-nullable column. So in testing, this usually works. But when you deploy this on a multi-million row database, then beware that this might also cause unwanted downtime when the database applies this non-nullable column. So we had this once, and the learning was like, don't add non-nullable columns if you already know that the table size is going to a...
Yeah, that's true. I mean, exactly. It means that if, for example, your column is non-nullable, then you have problems. And then what you need to do is relax this constraint between you are doing the migration, and when you finish the migration, then add the constraint again. This is, thank you. I mean, that in that book of microservice, one that I've shown, that this technique is explained. And it's like this, that you need to relax constraints before. And another thing is that when you copy data, you have a bunch of data. You're not going to copy like I've done here. Probably you're going to do some batches to not lock all your databases and doing batches and batches. And then, I mean that it's in a more complicated example than the typical ones, but it's not the most complicated example, let's say. But but batches and relaxing constraints are the solutions. Thank you.
I think we have time for one more question. Is there one? More. Okay.
Hi. So I have a question about the traffic shadowing deployment. So usually your current version and your new version will be working on the same database. So how do you handle writing requests? I mean, you would, like, if there's an insert, you would insert something twice into
it. Sure. Yeah, there are several techniques about this. The question is that if you're doing shadowing and you are doing a read, it's not a problem, but you're doing insert, you're inserting twice the same entry. The answer is, I would say there are 3 strategies. I will tell you the easiest one, but also it's the more risk one, which is like creating an attribute which is called synthetic transaction. And what you're just doing is like, if I see that this comes from a mirroring traffic, and Istio sets you a header saying this is a mirror traffic, right? Then I just said that the transaction is always rollback. It doesn't matter what's happening, it's always rollback. The problem is that you're putting this in your code. So if you miss to put this, then you will start doing double inserts. This is one of the problems. But it's the easiest one, right? Because it just put it rollback every time. The other way is using, for example, virtual DBs. Virtual DBs, for example, one is JBoss State, which is an open source project from Red Hat, which you defined that when you are doing a read, you do the read against the real database. But when you are going to do a write, you just start up a new trash database where everything goes there, and then when you are fine, then you just shut down this database. So the reads comes from the real database, the writes goes something that it doesn't matter. The third strategy is using Divisium and all this CDC stuff of, with Kafka events and so on and so far. But it should be possible, but I've never tried. But this, for me, this is the most complex one. So if you are not in a big team, then probably synthetic transactions is the one that works best for you because you have control of everything. You can do code reviews and say, hey, look, you need to put the transactions one. If not, then virtual DB probably is the best way to proceed.
Thank you.
So,
there's question.
Final question?
There, I guess. Yeah.
So if your service is idempotent, I don't think that would be a problem. If you can replay the same request again, like idempotency, shouldn't be a problem.
If you replay in case of mirroring.
Yeah.
Yeah, of course.
If it's idempotent, then you can send the same request twice, and you wouldn't create, two records.
Yeah, exactly. Yeah. This is what I mentioned, that you need to find strategies for not allowing that this happens. But even this is not the problem. The problem is not the duplicated at all. The problem, yes, it could be a problem, but the biggest problem is that what's happening if you do an insert with a constraint, and the one that succeeds in inserting is the mirrored one. And then the real one gets a constraint violation and get an error to your user. Your user will receive the error and maybe will say, okay, I'm going to retry. But then we will receive always the error because another request has just inserted the data there. And because in reality it's there. So the problem is not if it's duplicated. It is.
No, I'm just saying that the service should expect that to happen anytime because you can always get the same network request twice.
Yeah.
It should be normal in the microservice infrastructure. So
to
deal with duplicate key exceptions should be the norm, I guess.
Yeah.
That's what I'm saying. Just.
Okay. Well, yeah. But in this case, because you're saying about retries, yeah.
So, thank you very much.